For the inverse derivative, let's write out what condition needs to be given to us. The condition is this right here. So given f of x and g of x are inverses. As long as that is given to us, the following can be written. And by the inverses, if you're thinking about what does that mean? Back in Algebra 1 and specifically in Algebra 2 was, it's when f of x is equal to g prime of x. The part that I do want you to memorize is the following. So as long as this is stated, we can go ahead and write out the following. G prime of x is equal to 1 all over f prime of g of x. And yes, at some point, you'll need to get this memorized. So as you're working on the homework, write them down each time, okay? Because I know some of you guys are saying, I don't know how to study. Kinesthetic learning is also studying, okay? That's what when you're trying to spell something, you typically write it out and then kind of correct it. All right, so I'm not going to write the history behind this, but teach you how to use this. Is everyone okay with that? All right, so teaching you how to use it. Castro, read the first one. If
g of negative 2 equals 5, f prime of 5 equals negative half, then g prime negative 2 equals what?
Okay, so I should have also said that was part of the question as well. Oops. Let's start by writing out what we know. What is my x represented by? Negative 2. So let's write out by writing out g prime of negative 2. And I'm going to use the formula right above, but instead of x, plug in the negative 2. So 1 all over f prime of g of negative 2. And the first thing that we are going to solve for is the very inside of the function. G of negative 2. What is g of negative 2 given in the problem? 5. So let's write out 1 all over f prime of, and I'm replacing g of negative 2 with the 5. And then I see the following. F prime of 5. Is that given to us? So it will always be the case where as long as you're using the formula correctly, you can go back and see that the number is replaced with something else. So in this case, we have 1 over, isn't that negative 1/2? And when I multiply that by the reciprocal, it should give you negative 2. And if I have to show you multiplying by the reciprocal, that's going to be a sad day. I don't want to do that part. All right, let's go on to number 28. On number 28, let's see. Ian, go ahead and read number 28.
Let f be a differentiable function such that f of 3 is equal to 15, f of 6 is equal to 3, f prime of 3 is equal to negative 8, and f prime of 6 is equal to negative 2. The function g is differentiable, and g of x is equal to f, the inverse of f of x for all x. What is the value of g prime of 3?
Thank you. So I know this one did not say given the function are the inverses, but do I see this relationship basically right here? Yeah. So let's look at our what we are looking for. This guy right here is our equation right above. So let's rewrite this. G prime of 3 is equal to 1 all over f prime of g of 3. Now something weird is going to happen. When something is inverse, and I should actually kind of share something from the very top. Inverse basically means, let's say I have a number that is 2, 4. And that is represented as f of 2 is equal to 4. And if the function f is inverse of g, what I can basically do is take 4, 2 and also say g of 4 is equal to 2. So the bottom line is I could take my domain and range and swap them. Again, that is Algebra 1 concept. So let's go on to this one and see what piece I need. Looking at the very inside, do I see g prime of 3 or g of 3 anywhere by the given? No.
How is that so you can do?
What's that?
How is
Yeah, what can we do? Tell me, Luke.
So you take f of 6 equals 3 and make it g of 3 equals 6.
Nice. G of 3 is equal to 6. And that I can plug in into that inside, right? So I have 1 all over f prime of 6. And then I can say, well, is there f prime of 6? Is that given to us? So we know this is 1 over negative 2. So knowing the formula is going to be very, very crucial. All right.